So first of all, what is sequence? So sequence is just like basically a pattern of numbers. A pattern or just a collection of numbers. Collection of numbers in a order. In a order, collection of number in a order, just like if I am rewriting here some numbers 2, 6, 5, 9, 10, 13 and so on. This is a sequence. So now I'm writing a mathematical definition of the sequence. What is the sequence? A sequence is a function whose domain is the set of natural numbers. So what does it mean? So since the domain of every sequence is the set of natural numbers, so a sequence is represented by its range. So what is a f function? Function defined from natural number to real numbers. So what is the image set of this function? It will be f of 1, f of 2, f of 3 and so on. Is a sequence. So now I'm writing here some examples, just like if we are taking f of n is equals to 2n, then what will be the sequence? 2, 4, 6, 8, 10. This is a sequence. If I am taking just 2, 3, 4, 2, 3, 4 and so on, this is also in sequence. What is the meaning of the order in the definition? It means this is the first term, this is second term, this is third term, this is fourth term, this is fifth term, this is sixth term. So have you understood the definition of sequence? So now I'm introducing, there are two types of sequence. So types of sequence with respect of numbers, terms. So now first is finite sequence. So what is finite sequence? So finite sequence is a sequence in which have finite number of terms. It means it has finite number of terms. Just like if I'm writing here 2, 4, 6, 8, 10, 20. These are the finite number of terms. Now if I am writing another example, 3, 5, 9, 13, 14. This is also a finite sequence. Now I am introducing the second type of sequence, that is infinite sequence. So clearly we can see what is infinite sequence. It has infinite number of terms. So the example is just like if I'm writing fn is n square, then what will be sequence? 1, 4, 9, 16, 25, infinite number of terms. If I'm writing the all the set of the all the even numbers 2, 4, 6, 8, 10 and so on. So clearly have you understood the two types of the sequence? Okay, so now I'm introducing another term which is progression. Progression. So what is progression? Progression is progression is just like a set of numbers which has following particular pattern. What is progression? A set of numbers which follows a particular pattern. So clearly, what does it mean? It means if like we have a set of function, set of numbers a1, a2, and so on, then these doesn't matter it is finite or infinite, but it follows a particular pattern. Just like if I'm writing fn is equals to n square minus n, then what will be the set? 0, 2, 6, 12, 20, 30, 42 and so on. It follows a particular pattern. It's just like if I'm putting n is equals to 1, then it will be 0, n is equals to 2, then it will be 2, n is equals to 3, then it will be 6, n is equals to 4, then it will be 12 and so on. So it follows a particular pattern. Like we are not just writing the random numbers. We are just putting the values in that form in the pad formula and we will get the sequence. So now by the by the definition of uh, sequence and the progression, I'm writing here a special case of that thing, that is arithmetic progression. Arithmetic progression. So what is arithmetic progression? Arithmetic progression, basically it's a sequence. So a sequence in which each successive term is obtained by adding a constant number, namely d, in the preceding term. It means if I'm writing here a sequence, that is a1, a2, a3 and so on, then first if I'm assuming first term is a, then what will be the second term? If I am adding a fixed number d, then what it will be? A plus d. Then what will be third term? I am adding d in the second term, then what it will be? A plus 2d and so on. So if I want to write another term of this AP, then what it will be? First term a, second term a plus d, third term a plus 2d, fourth term a plus 3d. Then what will be another term? A plus n minus 1 into d. Clearly? So this is the formula to find the nth term of a sequence. Okay. So now right here note. What is a note? In an AP, the difference between two consecutive terms should be same. Just like if I'm writing AP, A2, A3, A4 and so on, then A2 minus A1 which is equals to A3 minus A2 which is equals to A4 minus A3 and so on, and this is equals to D. What is D? D is common difference. Common difference. Okay. So now if if we have to check whether this is AP or not, then what definition we will use? We will use this definition. We will use this definition. In an AP, the difference between two consecutive terms should be same. Just like if I'm writing here a sequence 2, 4, 8, 10, 12, and so on. Difference between these two consecutive terms 2, 4, 2, 2. So we can clearly see that the difference is not same. So this is not an AP. If I am writing here another example, 3, 10, 17, 24, 31, and so on. So difference between these two terms 7, 7, 7, 7. So all are equal. It means this is an AP. Now I'm writing here a question that find the number of terms in a sequence so now what is the solution for this? First of all, we have to check whether this is AP or not. So clearly we can see the common difference of these two terms 3, 3, 3. So this is an AP. Now we can use the properties of AP in this sequence. So what are the first term? First term is 4. What is the common difference? Common difference is 3. How we will find it? 7 minus 4. So now common difference is 3. Now as you know, the nth term of the formula of nth term of an AP is a plus n minus 1 d. What is an? An is 82. We have to find the n value of n. So 82 is equals to 4 plus n minus 1 3. So n minus 1 3 will be 82 minus 4, which is 78. So n minus 1 is equals to 78 by 3, which is 26. So n is 27. So there are 27 terms in this sequence. Okay. So now we are taking in another question, that is if log a log ab log ab square are in AP, then find its nth term. We have given that the first term is log a, second term is log ab, third term is log ab square, and so on. Then we have to find what is the nth term. So clearly first term, namely a1, which is log a, the common difference d, which is equals to log ab minus log a. So what is log ab? I'm writing here the logarithmic formula log mn, which is equals to mn, which is equals to log m plus log n. Log m by n, which is equals to log m minus log n. Log m raised to the power n, which is equals to log n log m. These are the three basic formula for logarithmic. So now for log ab, which is equals to log a plus log b minus log a, then it will be log b. So common difference is log b. Now, what is the formula of nth term of an AP? An is equals to a1 plus n minus 1 d. What is a1? a1 is log a plus n minus 1. What is d? Log b. Log a. Now I'm using this formula for here. What is the n log m? Or what we are given here, n minus 1 log b. Then what it will be? Log b raised to the power n minus 1. So here I am using this formula log m plus log n. Then what it will be? Log mn. That is log a b raised to the power n minus 1. So what is the nth term for this AP? An is equals to log a b raised to the power n minus 1. Okay. So now we have to write an observation. So now we have to write an observation. And what is the observation? Uh, Common terms of two APs with common difference D1 and D2 respectively are also in AP with the common difference LCM of D1 D2. So what is the meaning of this observation? It means we have given two APs like A1, A2, A3 and so on, and B1, B2, B3 and so on. And what is the common difference of first AP, which is D1? What is the common difference of second AP? It is D2. Then if we are creating a new sequence, if we are creating a new sequence in, if we are taking the if we are taking the common terms of these two sequence, then we are writing here a new sequence, then it will be also in AP with the common difference LCM of D1 comma D2. Now I'm writing here example. First is, if I'm writing here first AP is 2, 4, 6, 8, 10, 12, 14, 16, 18 and so on, and with the common difference 2. Now if I'm writing here another AP which is 3, 6, 9, 12, 15, 18, 21, 24 and so on. D2 is 3. So now I'm writing here the new sequence with the common terms of these two APs. It will be 6, 12, 18, 24, 30 and so on. So clearly we can see this is an AP because the common difference of every two consecutive terms is 6, same, and the common difference of this new AP is 6. Now I am claiming that the common difference of the resultant AP should be LCM of D1 and D2. So what is LCM of D1 and D2? 2 comma 3, which is equals to 6. So clearly we can see. Okay. So now we are moving to another observation. So now the another observation is in each term of an AP is increased with summation, increased, decreased means subtraction, multiplied or divided by a non-zero number, then the resultant sequence is also an AP. Okay, so what I'm writing here, if we have given an AP and I want to just I have just a constant number which is equal, let assuming which is k. If I want to uh, add every number, subtract in every term, multiplied in every term, or divided in every term, what I want to do, then the resultant sequence will be also an AP. Now we can clearly see if we have an AP with the common difference D. Now I'm assuming a k, which is k is not equals to 0. Then if I am adding in the previous sequence, then the resultant sequence common difference will be same, D. If I am subtracting a constant number k, then the resultant sequence common difference will be same, D of the previous one. If I am multiplying in each term of the previous sequence, then the resultant sequence common difference will be k, D. If I am dividing in every term of the sequence, then the common difference of resultant sequence will be d by k, where k is not equals to 0. So now let us assume I am proving for just one operation, like I want to prove it for multiply. Like we have an AP, then the terms of AP will be A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. So clearly, if I am multiplying every term with the k, then what will be the new sequence? Ka, Ka plus Kd, Ka plus 2dk, Ka plus 3dk, and so on. So clearly we can see the common difference of the difference of every consecutive term is Kd. Or if I want to prove it for the general terms, then what it will be? If I am writing the resultant sequence will be bn minus 1. Oh, sorry. So clearly this is an AP. Now I want, and with the common difference KD. Okay. So now here's an question, and what it is? It is A, B, C are in AP. Then prove that AB inverse, CA inverse, BC inverse are also in AP. So now I am proving by the definition of the AP. So first of all, what are given that A, B, C are in AP? It means the difference of B minus A, which is equals to C minus B. Now I have to prove that these three terms are in AP. That means the difference of two consecutive terms should be equal. That is CA inverse minus AB inverse, which is equals to 1 upon CA minus 1 upon AB. By the taking LCM ABC, what it will be? B minus C. If I'm writing here the value of B minus C from here, then what it will be? What it will be? A minus B upon ABC. So this is A upon ABC minus B upon ABC. What it is? 1 upon BC minus 1 upon AC. Then this is equals to BC inverse minus AC inverse. So what we have proved? CA inverse minus AB inverse, which is equals to BC inverse minus AC inverse. It means AB inverse, CA inverse and BC inverse are also in AP. This is the proof by the definition of AP. Now I'm proving it with the observations. So how we can prove it? So this is method 2. Now what are given that ABC are in AP. Now if I am dividing each term by a fixed number, then the resultant sequence is also in AP. That is A upon ABC. I am dividing with the ABC AP. So now what it will be? It will be 1 upon BC, 1 upon AC, 1 upon AP, also in AP. It means BC inverse, AC inverse, AB inverse, also in AP. If I am rearranging the terms, then it means if I want to replace first term to last term or last term to first term, then there is no changes in the property of AP. So AB inverse, AC inverse, BC inverse also in AP. So this is what I want to prove is. So this is just a 4 or 5 term proof. So you can use these observation to prove this. Now what we want to what we have seen all the theories or questions for the formula of nth term of an AP. Now I want to introduce the sum of the nth term of an AP. Sum of the nth terms of an AP. So nth term. So what is the sum of the first term? A1. Second term A1 plus A2. Third term A1 plus A2 plus A3. And Sn, which is equals to A1 plus A2 plus and so on An. It means summation An. So now how and what is Sn minus 1? What is Sn minus 1? It will be A1 plus A2 plus An minus 1. So now if I want to write it, then what term will be remaining? It will be A. So this is also a formula to find the nth term of a sequence. Then what we have given that then the sum of the nth term and sum of the n minus 1 term. Then we can find the nth term. Okay, so now focus on the Sn. Sn is a1 plus a2 plus a3 and so on an. So what is a1? A1 is a. What is a2? A plus d. What is a3? A plus 2d and so on. What is an? An is a plus n minus 1 d. So a comes nth times, so it will be na, then d plus 2d 3d and so on n minus 1 d. If I am taking the common d, then what it will be? A plus 1 plus 2 plus 3 plus and so on n minus 1. And this is the sum of the n minus 1 natural numbers. Then what it will be? Na plus d n n minus 1 by 2. If I am taking common n by 2, what it will be? 2a plus n minus 1 d. So this is the basic formula to find the sum of n terms. Now if I am rewriting here, Sn is equals to n by 2 a plus n minus 1 d. So Sn will be a plus an. Okay, this is also a formula to find the sum of n term of an AP. These both are equal, but we can use the suitable formula by the given data. So now if we have given that, if I have a question, what is the question? Find the sum of all 3-digit natural number which on division by 7 leaves remainder 3. So what is the sequence for these given data? What is the sequence for these given data? It will be 101, 108, 115, 112, and what will be the last term? Last term will be 997. Clearly we can see that this is an AP. So we have to find that what are the total number of terms in this AP. So A is 101, D is 7, and AN is 997. So AN is equals to A plus n minus 1 D. 997 is equals to 101 plus n minus 1 7. So n minus 1 7 will be 896. So n minus 1 is equals to 1 2 8. So n is equals to 129. So clearly we can find the sum of the n terms will be 129 by 2, 2 into 101 plus n minus 1, 129 minus 1, and what is d? So it will be 129 by 2, 202 plus 128 into 7. What it will be? 6, 9, 8. It will be 129 by 2 into 1098. It will be it will be some number. We can find 549. So 129 to 549. This is the method one. If I want to use the another formula, then what we have given that a is, what is a? A is 101. What is an? An is given 997. So Sn will be n by 2, 192 upon 129 upon 2, 10 plus 997. 129 by 2 into 1098, same as the previous one. Okay, we can use both the formula, answer will be same. So now I'm writing here another question. The ratio between the sum of n terms of an AP is 3n plus 8, 7n plus 15. Then find the ratio between their 12th terms. What we have given that as Sn, we have given that two sequences Sn or Sn dash will be 3n plus 8 upon 7n plus 15. Then what is Sn? If I'm a plus, sorry, n by 2, 2a plus n minus 1 d upon what is Sn dash? N by 2, n minus 1 d dash. It will be 3n plus 8 and okay. Clearly we can remove these two terms. Okay, so now what we will get, if I am dividing by 2 in the numerator and the denominator, because we want to find the ratio of finite terms. So we have to make 2a to a. So what it will be, a plus n minus 1 by 2 d upon a dash plus n minus 1 by 2 d dash will be 3n plus 8 upon 7n plus. So we have to rearrange these terms in a plus 12. For the 12th term it will be a plus 11d upon a dash plus 11 d dash. Then what we have to put, n is equals to what we have to make, n minus 1 by d a dash plus n minus 1 by 2 d dash, n is equals to 23. So what it will be, 3 dot 23 plus 8 upon 7 dot 23 plus 8. So what it will be, it will be 77, it will be 77 upon 176. If I am dividing these numerator denominator by 11, then what it will be, 7 by 60. So this is the required answer. Okay, so now there is another question. If sum of n terms of a sequence is given by then find it 50th term. So think about it, how we can solve this. We have given the sum of the formula of sum, and we are asking that term. So we have already seen that an is equals to sn minus 1. So sn is 3n square minus 4n minus sn minus 1 is 3n minus 1 का whole square minus 4n minus 1. So what it will be, 3n square minus 4n minus 3n square plus 3 minus 6n minus 4n plus 4, 3n square minus 4n minus 3n square minus 3 plus 10n minus 4. So what it will be, 6n minus 7. So now we have to find the 50th term, that is a50, which is 6 into 50 minus 7, then it is 293. This is our required answer. So now I am writing here a property for an AP. Property of an AP. What is the property of the AP? The sum of the term of an AP equidistant from beginning and end is constant and equals to the sum of first and last term. So what is the property? Property is the sum of the term of an AP equidistant equidistant equidistance from beginning and end is constant and equal to the sum of first and last term. So now what is the meaning of this property? It will be if we have a1, a2, a3, a4 and so on, an minus 2, an minus 1, an. It means a1 plus an is equals to a2 plus an minus 1 plus, which is sorry, not plus, equals to a3 plus an minus 2 and so on. The sum of these terms will be equal. How we can prove it? The sum of these terms, a plus n minus 1 d, 2a plus n minus 1 d. Sum of these two terms, a plus d, a plus n minus 2 d. It will be 2a plus n minus 1 d. Clearly we can prove it for every term. Okay, so I hope you have understood the theory of arithmetic progression. So now you can solve all the question. Okay, thank you.